All right, hello everyone. This is Physics 221, Lab 5. This is Rose Ring, and my name is Alex, and I'll be giving you a quick presentation on this lab. This is just a YouTube link for the experimental video, and you guys can click that on my link below to watch it for reference. So these physics concept here, we have Newton's first law of motion, or AKA inertia, and an object basically will not change its motion unless acted on by an unbalanced force. So if it is at least at rest, it will stay at rest, right? And if it's in motion, it will remain at the same velocity. So object with a greater mass have more inertia, and it takes more force to change their motion. And it's just a little bit of a diagram right here, as you can see. And then we have Newton's second law. It's F equals ma, force equals mass times acceleration. And essentially, the force acting on a moving object is the product of the mass and acceleration. So this is a tracker analysis of the rope swing. We can see that when the swing is done, it's slowly decelerating at a more of a constant velocity. And these are our glow strip assumptions. So our initial velocity was at 0 for x-axis, 0 for the y, and 0 for the z. And our initial position for tracker was 0 for x and negative 0.0526 for y and 0 for z. Our mass of the man, we're assuming he's going to be 80 kilograms, and he is his height will be 5'6", and our LO is 45.72, and our K constant is 739.21 newtons slash meters. And this is just our glow strip code right here. We had the ball.m is essentially our start of the where the rope where he initially starts to swing. And excuse me, this is more his mass, and then these are the initial conditions for the velocity and the positions. And this right here will be our time beginning at 0 and our delta t when it swings. And this is more glow strip code of giving the potential energy, the initial potential energy, where the total energy is equal to, and the K for kinetic energy. And this is just our formula for L and L hat. And we have it also to consider that gravity is also involved in this case when we're doing the rope swing. And this is more code of how the rope swing changes while throughout the experimental video. And we have the S spring is equal to negative K, and as you can see, S times L hat. And we have an F nat as it's going to be equal to S spring times, S spring plus force of gravity. And this is more glow strip code continued. This is just essentially our curve plot. So for the next slide that's coming up, it's going to be the computational graph, and these are just the little arrows for the computational graph. So this is the graph right here. I have labeled the energies that's on the graph on the side right here. So K kinetic energy is blue. It's in going from 0 to 1.5, and UG is red, and it seems it's like it's almost at a constant energy, and US is green, and it's going towards 0 to 1.5, and our delta change of energy is orange. So some sources for this error is that air resistance was one of them, human error on tracker, and assumptions of the height and mass of man, and also the dates point for accuracy. And these errors have can also affect our data and how it would possibly affect like the results of the data. This is all I have for you guys. I hope you guys enjoy this video, and thank you so much for watching.